The task here is to use paint data, so paint data widget. I think I've shown it before, so it's a very simple widget. You just draw shapes in the widget, and here you have labels, right? So this can be used as classes. So these are the blue points, and then if I switch, I can paint red, I can paint more than one, so more than two, so I can paint 3 classes. And here, so here you have the brush, you have the put option, which puts a single point on the plot, and you can play around with radius and intensity. So this is your canvas for today, for this task. And the aim is to paint the data as you see it here on the left side. So one would be these 2 columns, and the second one would be split diagonally, and so on. If you don't want to paint, you can download the data from the link that is in the PDF file. So if you don't feel like playing around, you can also just use existing data and then load it with the file widget. So the task is to figure out which classifiers work well with which data set, right? Okay, so let's say this is data set A, B, C, and D. And then you will tell me also which classifier is the worst performing, so which one fails on majority of data sets, how the tree looks like in the tree viewer for this data set, so data set C. And then you will edit some parameters in the tree widget. So I will just show you what I mean by this. So if you're using tree, you will use this here, limit the maximal depth, the maximal tree depth to 2. And this will just basically say don't grow further than level 2 to the tree. Okay, you need to have it on. All right, so the task was to draw these data sets and to answer. So which classifier works well with A, B, and A, B, C, D? So I prepared this data like this, and I will use data table just to switch between data sets. So this is just a workaround. And then I will use, so predictions from these models, and I will use scatter plot to show the results of predictive models. And for example, here, now their points are colored by class, and I can color them by tree. So tree seems to work quite well for this data. Logistic regression, random forest, SVM, and KNN. So nothing changes here, and this is the same as the original data set. So the data set looks like this, which means that all the models worked for this very simple data. Okay, so when we have this, so the idea is, by the way, this, right? So looking at the white line, now I'm coloring by majority. So if majority of the points in the region are blue, the region is going to be colored blue, and the same for red. So here I'm looking at this white line, and this is the decision boundary for the classifier. So if decision boundary is linear and very simple, it doesn't matter which classifier you choose, okay? They're all going to work. Now, let's look at data set B. So this now is not a straight line, but it's a diagonal line, okay? So ideally, the classifier would be able to recognize this white line. Okay, and I will now switch the data set to B. And let's see what happens, okay? So this is the result for the tree. So you see some misclassifications here and here. logistic regression, random forest, SVM, and KNN. So the only one that doesn't work is the tree, which makes mistakes here. So what does the tree do, right? If you look at the data in tree viewer, it makes cuts, right? So it's cutting the space. So here it makes a cut based on X, and if X is larger than this value, or well, smaller than this value, or larger than this value, it will make a decision which class is purer. So it's cutting the data set in straight lines. And the problem with tree is that it cannot handle diagonal decision boundaries. So this is why you see here, there's like a square. You see kind of a square happening here. So this is the limitation of the tree. It can only cut in vertical or horizontal lines. So maybe it could cut the space into very small sections to imitate the diagonal line, but this would be overfitting a bit, because the tree would be huge with having all these micro cuts for imitating diagonal. So for diagonal decision boundaries, tree doesn't work well, and all the rest are good. Okay, now let's check dataset C. So dataset C is a bit complex. So it has this donut of blue points and the filling with red points in the center. Okay, let's switch to C. Yes. Okay, and now, so let's look at the scatter plot. The tree, as I said, you know, if it couldn't handle diagonal, it's not going to handle circles. So this is too much for the tree, and it just tries to find something that's close enough. So it fails, basically. Logistic regression also fails. So it just says majority blue. It doesn't even recognize these points in the center. This is because logistic regression is also a linear classifier, just like the tree. So the tree makes a cut here. Well, the tree is not a linear classifier per se, but it makes linear cuts. Like straight cuts. Logistic regression is a linear classifier that can handle diagonals, but this is not a diagonal, nor is it a straight line. It's, you know, I would have to kind of capture this circular shape. So this is something that logistic regression also doesn't handle. Random forest. Now this is interesting, right? Even though it's composed of many trees, which you saw how bad the trees are on this data set. But when you put many of them together in a random forest, boom, it can handle the data. This is really surprising because, well, random forest, as probably Blaž explained, is the wisdom of the crowd. So taking many trees, each one not being the best for this data set, but looking at the data from many different perspectives, it is able to capture this decision boundary very well. So random forest is one of the best and most popular classifiers still. So you see, it's really nice. SVM also does a great job. And why? Because, so I didn't explain a lot about SVM. So this is short for support vector machines. And what happens is, so it also, SVM is basically, if we take linear SVM, it's the same as logistic or linear regression. So it just makes like a straight cut in the space of the data. But so actually, not a cut. When I say a cut, I mean a plane. So like a piece of paper that that I have, right? So if I have a piece of paper, I cannot cut this. So a straight piece of paper, I cannot cut this donut, right? But what happens if I kind of just curve the piece of paper a bit? So then, okay, of course, now I'm curving it in one way, but let's say I just pull the center of my piece of paper up, and then I can capture C2 and keep C1 separate. So this is what SVM does. It transforms a plane, a hyperplane, into a curved plane. So it uses some kind of a trick to transform the straight shape into non-straight shape, like here. And KNN is K nearest neighbors. It just looks at the neighborhood of the data points. It's very simple. If the closest point is red, closest K points are red, this point is going to be red. So of course this works well. Okay, now for the final data set D, which is like this. So now we don't have, we cannot cut in straight lines. We cannot even, it's not a diagonal. We'll see what happens. These are like small clusters of data points. Okay, so now I'm switching to D. And now let's check the tree. Again, the tree is not very good. Okay. By the way, sorry. So you probably had a bit different results here. So now I'm actually skipping. Where is this? To the fourth question. I accidentally had 3 set to 2. So I'm not sure what the default is, like 100 or something, I guess. So I wanted to say that here, so now we're answering the fourth question. When we limit the maximal tree depth, you're going to see that trees are going to fail. But here, so for some data sets, so this one is not too bad. This one actually is pretty good for the tree, but it's 100 levels deep. So if I look at the data, if I look at the tree, it's very big, especially for a two-dimensional data set. So if I had a higher dimensional data, tree would just grow extremely big. And we don't want trees to grow that much, because then we can overfit the data. So when we get new data points, it's going to be hard to fit the tree in this super cut space. So you probably had different results here for if you were using maximal tree depth 100. But it always pays off to check tree in the tree viewer, and if it's very complex for a simple data set like this, you shouldn't trust it because it can overfit very easily. Okay, logistic regression, the same, it failed as before, so it couldn't capture these data points. It just went with majority. Random forest, as expected, works quite well. So I think this is the same image as we had. SVM, it's not too bad, but there is some mix-up here. Probably because it couldn't fit the hyperplane to such details, so such a detailed data set. And as probably you can imagine, KNN is going to work great because it looks at neighborhoods. So this data set is perfect for KNN because it has small groups of same data points. Okay, so look at the tree with tree viewer for data set C. So now we just looked at it for D. I think this is the last thing that... okay, so I have to switch to C and have the tree at 100. So this is the same thing, right? It really grows fairly big for this data set. But tree with, you know, kind of unlimited depth or a large depth was able to capture this. Each model is best at a certain, like for a certain data set. So they're all different, and some are better, some are worse. So, I mean, trees are mostly not used because they can overfit very easily. Instead, we have random forests. But all the others, logistic regression, SVM, and KNN, are used still fairly often. So depends on the kind of data you have. Told you about this as well.